In this project, we're working with an Arduino Uno and building a simple interactive circuit on TinkerCAD that uses a push button to control two LEDs, demonstrating basic digital input and output functionality. The components used in this setup include one Arduino Uno board, a breadboard for easy prototyping, a push button, two LEDs, one red and one green, 3 current-limiting resistors, and jumper wires for making connections. The red and green LEDs are connected to digital pins 3 and 2 on the Arduino, respectively, with 220 ohm resistors in series to protect them from overcurrent. The push button is connected to digital pin 4 and wired with a 10K ohm pull-down resistor to ensure that the input reads low when the button is not pressed, avoiding any false triggering. The power and ground from the Arduino are supplied to the breadboard rails to distribute power across the circuit. This creates a simple timed event controlled by a button press, which could be useful in real-world scenarios such as a pedestrian crossing light, a machine operation cycle, or any application that requires a visual response to a button trigger. This project is a great introduction to working with digital inputs and outputs on the Arduino platform, and using TinkerCAD makes it easy to simulate and visualize the working without needing physical components. It helps you learn the logic of input detection, conditional responses, and timed actions, all of which are essential building blocks in electronics and embedded systems design. Now let's talk about how the code works. In the setup function, we configure pin 4 as an input for the button and pins 2 and 3 as outputs for the LEDs. Inside the loop function, the red LED is turned on by default by setting pin 3 high, and the green LED is turned off by setting pin 2 low, indicating an idle or waiting state. When the button is pressed, the Arduino detects a high signal on pin 4, which triggers a switch in the output state. Pin 2 is set high, turning on the green LED, and pin 3 is set low, turning off the red LED. This change indicates an active state or an event trigger. The green LED stays on for 10 seconds using a delay function before the circuit resets to its original state, with the red LED on and the green LED off.